Okay, so because e is the natural base for logarithms, logarithm base e are called the natural logarithm, and the function y is equal to log e of x, that it is y is equal to log e of x, is called the logarithmic function. So to distinguish it from other logarithmic functions such as log base 2 of x and log base 10 of x that have other bases. So what we're going to do is we're going to have a look at a table of values. I'm going to compare it to e of the x, and we're going to compare this one to log of base e to the exponential e. So e and x and e to the x, and we've already done this one in a previous video, so it shouldn't be super foreign. But e to the, well, we'll do the easy ones. E to the power of 0 is just 1. E to the power of 1 is just e. E to the power of 2 is e squared. And then going the other one, we've got 1 over e and 1 over e squared. So that's e to the x. Now what we're going to do is we're going to have a go at doing log e of x. Now what you might notice is on your calculator is that we don't have a button, well, we'd have to do the change of base, I should say, for our log, and that would take a long time. But what we do have is we have this button that's called ln. Now this stands for this is the natural log. This is the log base e. So if I do, for example, log e of e, okay, it should be equal to 1. So log e of e, power of 1, and that should give us 1, just like that. And in fact, I've actually done my things around the wrong way. What we're going to do is to show that this is the inverse. Okay, if I put 1e squared and 1 over e and 1 over e squared into the log function, it should turn out and give me the and it should give me 0, 1, 2, negative 1, negative 2. So log of 1 is equal to 0. Okay, so that's the opposite of this one on here. Okay, so that's that opposite. Okay, log of e to the power of 1 is equal to 1. Okay, so that's the opposite of this one here. Okay, log e2 is equal to 2, which again is the opposite of this one. Now just to sneak it in a bit, instead of doing 1 over, I'm just going to put the negatives in there. So minus 2, which is the opposite of this one. And of course, minus 1, which is the opposite of that one there. So your natural logarithm base e is essentially your inverse function. So this and this are inverses. Okay. So let's have a look at the actual function of y is equal to log of x, or natural log of x. So as I said, the calculators prefer ln, okay, but here we go here. So if I compare this to y is equal to e to the x to begin with, as you'll notice, we have that reflection in the y is equal to x, which I did try to say in the other video, but that's not quite right, but it is in this one, so it's a reflection. So if I add in y is equal to x, okay, and I change the color of that because we don't want that, and I change it to a dotted line, you'll see that it does make that reflection like that to y is equal to x. So some quick things about the logarithmic function. The domain is all x greater than 0, because any number that is 0 or bigger, bigger than 0, because 0 can't actually go into this, will give me a value in return. So for example, if I tried to put log of 0 in, I get a math error because we can't have 0 answers in our exponentials. Okay, the range is all real y, so even though it does look like it slows down very quickly, this will actually keep increasing. Okay, it just increases at a decreasing rate. So it is still going up, and you can see it's still going up, and it always goes up. So technically, this will get to infinity. Well, not technically, it will. It gets to infinity, so it's going to keep growing and growing and growing, okay? But it does get up to infinity. Now, the y-axis is our asymptote this time. So with our exponential, our asymptote was the horizontal line, x is equal to 0. But for our logarithm, our asymptote is the vertical line, y is equal to 0. So again, that's that reflection on the y is equal to x. Now, as x approaches 0 from the positive side, so as in our 0, well, we get closer and closer to 0 going this way, then our y value gets bigger and bigger and bigger, or smaller and smaller and smaller, I should say, and it's going to shoot off to negative infinity. As x approaches positive infinity, so as we said before, as it goes further and further this way, our y is going to approach infinity as well. Okay, so it'll eventually get to infinity. Now the curve has gradient 1 at its x-intercept, so at this x-intercept here, if I put in the y is equal to x minus 1, okay, so the derivative of that tangent is equal to 1, of course, because that's the gradient. And as you can see, this... That's not putting me another one, but as you can see, this line has a gradient of 1 at that point there. And the curve is always concave down. So the exponential curve is always concave up, which means that, like if you're looking at this one here, like it's like a cave going upward. So like if I was to shoot a light at it, it would be this way. And this one is concave down. So it means that it's the arc, or the circular part, is inwards, going downward. The inward of it is going down. Okay, so just like before, we have some regular transformations of the exponentials, just like we have the regular transformations of the exponential function as well. Sorry, of the logarithmic function as well. So what we're going to do is we're going to have a look at 3 different types, okay? And again, just like before, we are going to hide the thing and talk about each one before we actually see what it is. So remember, this is the same as log base e, and what we're going to do is we're going to look at negative x. So we should remember that whenever we change x to negative x, what happens to our function is that it gets reflected in the y. So basically all of our 1s turn to negative, all our negative 1s or negative values turn to positive. So if I turn this on, basically this side should be coming out this way instead. And there we go. So that's those values there. Okay. Now let's do the other easy one where we take the negative of log of x, and essentially for this one it's going to be a similar sort of thing, but it's going to be reflected on the x-axis, and there it is there, so that makes that one there. Now remember before we talked about exponential functions and the parabola, well, we do kind of have another parabola in this case. We've got a relation parabola, and again, like the other one, this one, you know, it starts out a much wider, and the logarithms, so this one actually grows quicker than the logarithm. So the logarithm's a very, very slow growing function, but the sideways parabola actually grows quicker, or grows, you know, I guess, yeah, quicker negatively as well in that direction too. But that's just another little sort of, hey, it's a cool little thing to look at. Okay, if I put log x and then I put minus 2 on the outside, so another pretty obvious one as well. Effectively what we're doing is we're changing the y to y plus 2. So what this should do is it should move it down 2 in the negative direction. And there you go. So basically all our values have been shifted 2 down. Okay, and as you can see, so it makes it a pretty consistent 2 lines going across like that. Okay, and of course the difference, remember we're looking at the difference between this vertical, it should be always 2. And so when we get down here, even though it does look like it's on top of each other, again, there is still that difference that you can see. So that's that one. Okay, and the last one we're going to look at is if we replace the x with something. So again, this is just like when we replace the x in any other function with an x plus 3. So it should shift this 3 to the left. And there we go. So we go from 1 to minus 2, and all our values shift 3. And again, it's going to give some pretty consistent values along here, and these lines are literally almost parallel lines. Not quite, but they almost are. And then it's going to be growing, like it's going to look closer and closer, but there should still be that distance. Remember, so we're looking at the horizontal distance now, not the vertical distance, but the horizontal distance all the way through this will still be equal to 3. So it's always equal to 3. So that's pretty much all we're going to look at for logarithmic functions. Again, if you're graphing these, a table of values is always useful, and it's always a good place to start. With that being said, that's the end of the logarithmic function, and I'll see you guys in the next video.